In this video, we're going to talk about telescoping series. To help illustrate what a telescoping series is, it's probably best to look at an example. An example of a telescoping series is the sum from k equals 1 to infinity of 1 over k squared plus 7k plus 12. Now, if I were to ask you to integrate this function, what would you do? I know it's been a while, but we all know that to integrate a rational function, we use partial fractions. So let's try the same thing here. First, we factor the denominator into k plus 3 times k plus 4, and then we compute the partial fractions decomposition. I'll leave out the details, but the punchline is that we get the sum from k equals 1 to infinity of 1 over k plus 3 minus 1 over k plus 4. Now, the series certainly isn't geometric, so the only other thing we know how to do up until now is to look at the partial sums. Let's try that. The first partial sum is just the first term, which is 1/4 minus 1/5. Now, we could combine these fractions to simplify, but I'm going to leave them split apart, and you'll see why in just a second. We compute the second partial sum, which is 1/4 minus 1/5, plus 1/5 minus 1/6, and the 1/5s cancel. This canceling actually continues for all of the partial sums. For example, the third partial sum is 1/4 minus a fifth, plus a fifth minus a sixth, plus a sixth minus a seventh. And so the 1/5 and the 1/6 all cancel. And that's why this series is called telescoping. The series collapses in on itself, just like one of those old pirate telescopes you see in the movie. The moral of the story is that in the nth partial sum, all of the middle terms are going to cancel, and we'll be left with just the first term, which is a fourth, minus the last term, which for the nth partial sum will be 1 over n plus 4. Now we can compute the sum just like we did before by taking the limit of the partial sums. That is, the limit as n goes to infinity of 1/4 minus 1 over n plus 4, which is just a fourth. So we found that this series converges, and we found that its sum is 1/4. Just as a note, this pattern works for any series of the form sum of f of k minus f of k plus 1. For instance, in the example we just did, we had f of k is equal to 1 over k plus 3.